Hi everyone, it's so nice to see those who love physics and math. You could call me Mr. Ivan, and today we'll talk about logarithmic equations. And we'll talk about the method of taking logs of both sides, okay? Let's pay attention to the equation written on the whiteboard, okay? We have x to the power, and the power itself is log x base 3. It's on the left-hand side. On the right-hand side, we have 81. How to proceed? Let me move it a bit to the left. And literally, we will now take logs of both sides. Means I am writing log x to the power log x base 3 equal to, and again, taking log of the right-hand side, log of 81, like this. You probably want to figure out, does it mean that we take common logs with the base 10? And I would say no. The main hint or the main idea here is to figure out the best base while taking logs of both sides, which base those logs should have. And we could figure it out by paying attention to what is written. We have in the exponent, in the exponential part, log x base 3. On the right-hand side, we have 81. Both 3 and 81 are the powers of 3, right? 81 is 3 quadrupled. Means it's most likely good to take log base 3 on both sides. Obviously, logs should be of the same base. Okay, you cannot take log of 10, base 10, and log base 9, for example, on the left and on the right. You should take same logs with the same basis. Okay. Now, what happens next? Let's see. We have on the right-hand side, construction like this. What do we know about logarithmic identities? Okay, when we see those expressions. If we have log a to the power of n base b, it's commonly changed to n times log a base b, right? Well, now we have it. This is one of the rules we would need today to apply. Here it is. Means we can take this upper log, exponential log, down as a factor of the log we have, okay? Let me rewrite it with a different color. So log x base 3. This is the one I just brought down here. Times log of x already without any power, base 3. And it's equal to basically 4. Log 81 base 3 is 4. Now, left-hand side writing is basically about the square of the log. But I believe you do know that squaring the logs, we do not use the way we usually use for the squares like this, yeah? We use another one. We put the square in between log and x. Some students asked me, could I write this way if I like? Probably so. You would be understood. But this is not standard way to do, okay? Not to confuse others, better to stick to this way. In most cases, at least, okay? Now, I'll rewrite it in a way. Log x base 3 squared is equal to 4. Or possible just to write to take square roots of both sides, but I would not recommend it, generally speaking, just because you might forget that there could be two cases there, okay? And I would rather write this way. Log squared x base 3 minus 2 squared, which is 4. 2 squared, which is 4. And now I have the difference of squares, right? And I would never forget that it's log x base 3 minus 2 times log x base 3 plus 2. Cool. Zero product property. We can use it now. If the product of two factors is 0, means either factor could be 0. And this is the key to find the roots of the equation. Basically, we could just write that either log x base 3 is equal to 2, or log x base 3 is equal to negative 2, right? Well, and now by the definition of the log, x is the result, 3 is the base, 2 is the exponent, means x is equal to 3 squared, which means x is equal to 9. This is the first root. Then, from here, we know that x is equal to 3 to the negative second power, which means that x is 1 over 9, 1/9. This is our second root. And that's it. Equation is solved. This is the way how to solve log equations using the method of taking logs of both sides. And I hope you are fine with this approach. That's it for now. We'll have more videos and tips and examples and problem solving in future videos. Wish you all the best in your studies. See you and bye.